A browser agent can fail for a dumb reason. It cannot tell which button matters. It gets trapped behind a pop-up, or a redesign breaks the selector it was counting on. That is not only a model problem, it is a contract problem. On Fluid Coding and AI, we are going to build the same browser agent idea 3 ways: local Playwright, Cloudflare Browser Run over CDP, and WebMCP-style website tools. The useful question is not whether Playwright is good or whether remote browsers are useful. Both are. The sharper question is this: do browser agents become more reliable when a website exposes task-level tools, instead of forcing the agent to infer everything from pixels, selectors, and page structure? By the end, the verdict should be practical. You should know what local Playwright gives you, what Cloudflare changes, and where WebMCP-style tools actually change the reliability story. Most browser agent failures happen in the gap between intent and interface. The task says, book a hotel, file an issue, update an account, or extract a record. But the agent sees a page full of roles, labels, text, screenshots, overlays, loading states, and maybe stale selectors. Benchmarks make that gap visible. WebArena originally reported a best GPT-4-based agent at 1441% end-to-end success, while humans reached 78-24%. OS World also showed a large human gap on real computer tasks. The harder part is that one success number does not tell you whether an agent is deployable. Weber adds reliability and efficiency stress tests to existing web agent benchmarks. It injects things real sites do all the time: pop-ups, network errors, server errors, and delayed recovery paths. In one reported WebArena pop-up case, AWM dropped from 60% to 20%, and Steve dropped from 12% to 0. The point is narrow but important. A browser agent can pass a task and still be brittle when the web behaves like the web. The first build is local Playwright. This is the deterministic baseline. Playwright is excellent at browser actuation. Before a click, it checks that the target resolves to one element, is visible, stable, able to receive events, and enabled. Its locator model pushes you toward roles, labels, text, alt text, titles, and test IDs instead of brittle CSS or XPath chains. For a browser agent, that matters. Playwright makes clicking less flaky. It does not make the website's business process self-describing. A local agent loop usually exposes a small set of tools: navigate, inspect the page, click a locator, fill a field, evaluate JavaScript, take a screenshot, and maybe save a trace. Playwright MCP improves that loop because the model can use structured accessibility snapshots with no vision model required. That is stronger than pure pixels. But the agent is still translating intent into interface moves. If the page changes, a modal appears, or the task requires judgment across several screens, the agent still has to reason through the UI one step at a time. The second build keeps the browser control idea but moves Chrome off your machine. Cloudflare Browser Run, formerly Browser Rendering, runs headless Chrome on Cloudflare's network. It supports quick actions for screenshots, PDFs, scraping, structured data, and crawling. It also supports browser sessions controlled through Puppeteer, Playwright, CDP, or Stagehand. With Playwright, the important call is chromium.connect over CDP. Your script connects to a Cloudflare WebSocket endpoint with an API token, then drives the remote browser. Cloudflare changes the operating model more than the meaning model. Browser Run adds managed sessions, live view, session recordings, human handoff, direct CDP access, MCP client support, and WebMCP support in lab sessions. Cloudflare also says the move to containers increased browser creation and concurrency limits, while quick action response times dropped by more than 50%. That is useful infrastructure. It helps you observe failures, scale sessions, and recover from login or confirmation moments. But unless you add a structured tool layer, the agent can still be guessing what the page means. The third build changes the contract. Chrome describes WebMCP as a proposed way for websites to expose structured tools to AI agents. The page can declare tool names, descriptions, input and output schemas, and page state. It can use an imperative JavaScript API or a declarative form-based approach. Instead of asking, "Where is the checkout button?" the agent asks, "Is there a checkout tool with a schema?" That is a different failure surface. The website is no longer just something to click. It becomes a live tool provider. Cloudflare's WebMCP docs give a useful hotel booking example. In the tool first version, the agent lists tools on each page load, calls search location for Paris, filters for breakfast, starts booking, and completes booking only after human confirmation. Compare that with a click-first agent. It may need to inspect the search box, choose dates, interpret filters, recover from overlays, and hope the button names and layout stay stable. The difference is not magic. It is that the site has named the task boundary. Structured website tools can remove whole classes of errors. They can reduce misclicks, selector drift, screenshot loops, and ambiguity around which UI element represents the real action. They can return structured outputs instead of forcing the model to scrape meaning from a visual state. This is analysis, not a benchmark result. The public evidence I found does not yet compare the same model, same tasks, and same site across Pixels, Playwright locators, and WebMCP tools. So the narrow claim is safer for supported tasks on cooperating sites. Task-level tools should reduce UI guessing failures. The limits are real. Chrome says WebMCP is under active discussion and subject to change. Cloudflare's current WebMCP support uses lab sessions on Chrome beta, and those APIs work only in that lab session path. There are product questions too. A site has to implement the tools. Someone has to design schemas, permissions, confirmations, audit trails, and abuse controls. If a tool hides too much, the user may lose visibility into what changed. Structured tools reduce one kind of brittleness. They introduce a governance problem. The most realistic answer is a hybrid stack. Use Playwright or CDP as the reliable browser actuator. Use semantic locators and accessibility snapshots when the agent must interact with normal web pages. Use Cloudflare Browser Run when you need remote sessions, observability, recording, scale, or human handoff. Then, when a site exposes WebMCP-style tools, let the agent prefer those tools for the supported task and fall back to the page only when no relevant tool exists. Reliability comes from layering the contracts, not replacing the browser. Here is the practical verdict. If you are building today, start with local Playwright because it gives you deterministic control and great debugging habits. Move to Browser Run when infrastructure, concurrency, recordings, or human handoff become the bottleneck. But watch WebMCP closely. The important shift is not that agents get another browser API, it is that websites can expose actions at the level users actually mean. For browser agents, the future is probably not pixels versus tools. It is pixels, selectors, accessibility, CDP, and task-level tools working together. If this helped you reason about browser agents as a reliability stack, like the video and subscribe to Fluid Coding and AI. The next wave of agent tooling will not just be about better models, it will be about better contracts between models, browsers, and the software they operate.